Number 52. For each, for each pair of acids, label the stronger acid, draw the conjugate bases, and label the stronger base. And now, whenever the author says draw, I'm thinking draw the Lewis structure. So that's what I'm doing over here. I'm not sure that that's what needs to be done. I think maybe she means write the formula, but whatever, we'll do both. So we're given two different parts. So the first one is phosphoric acid. So here's the information for phosphoric acid, or formic acid. Formic acid. So we're supposed to label the stronger acid, draw the conjugate bases of these right here, both of them, and then label the stronger conjugate base. So we got phosphoric acid versus formic acid. Now, here, first of all, let me blow this up a little bit. Here is the Lewis structure for phosphoric acid, right there. H3PO4. There are the three acidic protons. It's a triprotic acid. And there's the Lewis structure for formic acid. And that's the acidic proton right there. Remember, any hydrogens attached to carbon are not acidic. Okay, so that's the acidic hydrogen. This is a monoprotic acid. So which one of these are the stronger of the two? Well, it's going to be the H3PO4 because it has a larger Ka. It's the Ka indicates how many of these molecules do lose their protons. The larger the Ka, the more of them that lose their proton, the stronger the acid is. Losing the proton, of course, means the acid is stronger. It has the greater ability to donate its proton in a reaction. So the Ka tells us that the phosphoric acid is stronger. So the conjugate bases, to write the formulas, you simply decrease the number of hydrogens by 1 and the charge goes down by 1. So here's the conjugate base formula, H2PO4 minus. And the Lewis structure, once you have this, is pretty easy to draw. Just take away any one of those H's, and there it is. And so the lone pair goes back to the oxygen, and now the structure has a minus charge. You can do the same thing for formic acid. You take away that proton, and that's the structure that you're left with. So that's going to be HCOO minus now. So if the phosphoric acid is a stronger acid, then its conjugate base will be weaker. Remember, the conjugate base, if it's a strong acid, then that means it doesn't want its proton back. So the conjugate base that it's left with doesn't want to grab back that proton to reform the acid. The stronger the acid, the less the tendency its conjugate base wants to reform the acid. But the weaker the acid, the stronger its conjugate base, or the more likely its conjugate base will want to grab back that proton to reform the acid. So this is the weaker acid. That means it has the stronger conjugate base. And the next one, part B, we have this time formic acid versus benzoic acid. Formic acid, benzoic acid. These are two carboxylic acids. Let me blow this up just a little bit. Two carboxylic acids. You can see the carboxylic acid group right there. The formic acid is attached to hydrogen, and the benzoic acid is attached to a benzene ring right there, a much larger molecule. And this time it's the formic acid which is stronger than the benzoic acid. The Ka is a little bit larger for this than it is for that. So formic acid is stronger than benzoic acid. It's the stronger acid. And the conjugate bases You can see the conjugate bases over here, the formulas. And remember, it's the hydrogen attached to the oxygen, which is the acidic hydrogen. So here's the formula for the conjugate base of benzoic acid, and they each have a minus charge. The charge goes down by 1. And here are the formulas right there. So this time, formic acid is the stronger acid, so benzoic acid is the stronger conjugate base.